My name's Emily Higgins, and I'm a scientist working with Reef Life Foundation to evaluate the coral reef communities that are growing on the IntelliReefs that we've had underwater in St. Martin. I examine animal and plant communities on artificial reefs and compare them to those living on natural reefs to see how they are similar and different and try to understand a little bit about how those communities function on both of them. Artificial reefs are a quick solution to build back that three-dimensional complexity that we've lost that would otherwise take decades to up to 100 years to reconstruct with just natural processes alone. They can be designed in any shape to achieve different conservation objectives and can be modified depending on species-specific needs in a certain region.
My name's Ian Kellett. I'm an underwater filmmaker, explorer, scientist. We have the IntelliReefs in the water for a year, so we brought down scientists and people who have lots of experience looking at man-made structures underwater and assessing whether this material is better than any other material. And what we found is it's covered in life.
So we're really interested in how the different oceanite materials perform with different environmental variables. Other than the corals themselves, we are also measuring species that could facilitate a coral community forming on the IntelliReefs. So the most common one that we look for is called Christus coralline algae, or CCA. It's a calcifying red algae that prepares the substrate for coral settlement. So not only does it chemically attract coral to the substrate, but it also actually facilitates their metamorphosis.
So here we are. We just dove on the IntelliReefs after a year plus being in the water, and there were 6 different recruits from a wild spawning event that landed and started to grow on the IntelliReef.
The results of our pilot study are really exciting because we found that the microtopography and complex matrix of pores created by our substrate provides an incredible amount of surface area for a diversity of life to settle, many of which are really important for reef development and feed a whole community of fish, which we found to be really abundant at sites with a high amount of vertical relief. We found that the oceanite IntelliReefs supported increased cover of calcareous species such as Christus coralline algae and brooding corals, as well as increased cover of important functional species on reefs such as sponges.
Our livelihood is based on people wanting to come here, and most of the people that work here either grew up here or have lived here the majority of their lives, so they've been able to see the difference in how the environment used to be in comparison to how it is now, and they're really passionate about preserving what we've got and trying to make it a little bit better.
We were amazed to see that the IntelliReef in the MPA supported almost 100% cover on all substrates, which was significantly higher than the natural reef.
We've just done phase 1 of an experiment. We've learned a lot. We've learned that we can invite wild coral to land and recruit on there. We've learned that the diversity is incredible. So much more to learn. There's so many different ways we can iterate this forward.